All right, let's jump right in. Today we're tackling a topic that is fundamentally changing everything, from healthcare to the way you shop online, machine learning. And no, it's not just about futuristic robots. It's a completely new way of teaching computers how to solve problems. So, let's get started with the one question that really changes the game.
This question, it's at the heart of everything. For decades, programming meant giving a computer a strict step-by-step recipe to follow. But what if they could just figure things out on their own, simply by looking at data? That's the huge shift we're going to explore.
Okay, so first up, let's break down how this new way of thinking is just completely different from anything that came before it.
This really nails the entire revolution in one go. On the left, you've got traditional programming. Pretty straightforward, right? We the humans write the rules, the computer just follows them. But on the right, whoa, machine learning completely flips that around. We give the computer the data, and we also give it the answers, and its job is to figure out the rules for itself.
And that reversal is the whole point. Seriously, it's not just some clever programming trick. This is what lets a computer actually learn from experience. It can adapt, it can get better over time, something a normal, static program just can't do.
I know, that might still sound a little abstract. So let's bring it down to earth. Let's look at a really high-stakes, real-world example to see what this actually looks like in practice.
Let's talk about healthcare for a second. Imagine you feed a machine learning model thousands of patient records. You give it all the data points, heart rate, BMI, age, sex, you name it. And crucially, you also tell it which of those patients eventually developed heart failure. The model then crunches all of that data, and it starts to see things, subtle patterns and connections that a human might miss. It learns what predicts risk. And just like that, you've created a tool that could literally help save lives.
Okay, so that leads to the big question, doesn't it? It kind of sounds like magic. How does a machine actually go from just a bunch of raw data to, learning the rules?
Well, let's walk through a simple example. Say you want to teach a computer to tell the difference between a cat and a bird. First, you feed it tons and tons of pictures, thousands of them, and each one is labeled cat or bird. Then the model gets to work. It starts looking for patterns. It might figure out that pictures with whiskers and pointy ears are usually cats, and pictures with feathers and beaks, probably birds. And here's the key. It's not just memorizing the photos, it's learning the rules. So the real magic moment, the real test, is when you show it a brand new photo it has never ever seen before, and it correctly says, that's a cat. That is learning.
So as it turns out, there isn't just one single way to teach a machine. There are actually three main styles of learning, and each one is good for different things. First up, we've got something called supervised learning. The best way to think about this, it's like learning with a teacher and a really big answer key. Imagine you're studying with flashcards. You get the question on one side, and the correct answer is right there on the back.
So this means you need data that's already been labeled by humans. Think about predicting house prices. You'd feed the model tons of listings with all the details, square footage, number of bedrooms, location, and you'd also give it the final sale price for each one. That's the answer key. The whole goal here is precision. The model learns to map the features of a house to its price so that eventually it can look at a new house and give a really accurate prediction of what it'll sell for.
All right, next up is unsupervised learning. And this one, it's a completely different beast. Forget the teacher, forget the answer key. This is more like giving a computer a giant, messy box of Lego bricks, no instructions, no picture on the box, and just saying, okay, go figure it out. Find some interesting patterns. It's totally on its own.
So yeah, this method works with data that has no labels. The goal isn't to predict some answer we already know. It's to find hidden structures, clusters, or weird things that we humans might not even see. Cybersecurity is a perfect example. An unsupervised model can analyze what normal network traffic looks like, day in and day out. Then, when it sees something that doesn't fit the pattern, some weird outlier, it can flag it as suspicious. That could be a hacker, and the system found it without ever being explicitly taught what a hacker's activity looks like.
And last but not least, we have reinforcement learning. This is all about learning by doing. Think about how you teach a dog a new trick. You give it a treat for doing it right. Or think about how you learn to ride a bike. It was just pure trial and error, right?
The way this works is the system basically tries something out in an environment. It makes a move. If that move gets it closer to its goal, it gets a point, a reward. If it's a bad move, it gets a penalty. So, over millions of trials, its one and only goal is to figure out a strategy that will get at the most rewards possible.
This is exactly how we've trained AI to master super complex games like chess. And what's wild is that they've come up with strategies that no human grandmaster had ever even considered.
All right, for our final section, let's pull all this together and talk about the one thing that really makes machine learning such a game changer.
Here's what you really need to remember. These models aren't static. You don't just build them once and they're done. They're more like living algorithms. They can keep learning, keep adapting, and keep getting better as they see more and more data.
And that really gets to the core of it all. Making predictions is amazing, don't get me wrong. But the real power, the thing that changes everything, it's not just the prediction, it's the adaptation.
That's the fundamental line in the sand. Think about a regular statistical formula. It's fixed. It does what it does and it never changes. A machine learning model, though, it can actually evolve. It can change its own rules based on new information, all without a person having to go in and manually rewrite the code.
So I'll leave you with this final thought. We're now building systems that don't just follow the instructions we give them. They learn and they adapt, all on their own. And as these algorithms get woven deeper and deeper into our daily lives, constantly learning from our world, you have to wonder, how are they going to reshape it?